Hi and welcome back to my channel. So in this video I want to talk about this thing that just arrived in my mailbox. As you can see, it's a rather big device. It weighs more than 1 kilogram. It's all metal and it is a variable attenuator, so it has one input and one output, and the idea is that you can regulate the attenuator on the RF signal starting from, let me see if I can show you, 6 dB. Yeah, probably now you can see, and by moving the wheel up to 66 dB. Okay, and so I thought it was pretty handy. It's a pretty handy thing to have in this sort of home lab kind of environment. And let me show you what it is precisely. It is this model from WEINSCHEL, 940-60, and it works from DC to 4 gigahertz. Okay. One interesting thing is that this is built with military requirements, so it meets military requirements here, and so this means that it's pretty well made, so it's going to last a long time, hopefully. Anyway, these kind of attenuators you can find on eBay, and as you can see, it's pretty easy to find above $100, 130, 110, something like that. I found a very good deal from these sellers that is doing international deliveries, so everybody watching this video could potentially buy. And as you can see, the cost is 48 euros, but I made an offer. You can click here and make an offer for 32 euros. So in total I paid 50 euros, 32 plus 18 of shipping, and I think it's a pretty good deal for what this thing is. So if you're interested, there are still a few of them here. So yes, the purpose of this video is going to test the behavior of this attenuator, see if it works properly, and yeah, that's basically it. It's going to be a very short review. By the way, this attenuator is sold as it is, as you can see. So there is no metal. I mean, you can put it like that on the desk, but you know it's pretty unstable. Potentially it can fall. So I thought I could build. You know, I just made up this this thing here, and so I'm going to apply it here right now, and to give it just a little bit of more flexibility. So let me do that right now. Okay, so I've done it. So as you can see, I've fixed this cardboard base, which I painted in black, with just 2 bolts here, and it works pretty nice. Now it's pretty stable, it doesn't go anywhere, and it's good to go. In the future, perhaps it would be nicer to make a metal stand as a DIY project or something, but for the moment this is ready to go. And so let me verify its behavior using my spectrum analyzer. So let me show you the view of the spectrum analyzer. Is there. So I'm going to use the tracking generator, and so let me show you the tracking generator signal. So it's going to be a signal at 0 dBm. Let me activate it. So as you can see here, we get a pretty flat signal. This is the reference signal as emitted by the tracking generator, and it's at the moment is a flat line at 0 dBm. Okay, so I'm now going to connect it to the attenuator, and to do that I need to plug some adapters, because these are end connectors, and the cable here is SMA cable. So let me do the connections. Okay, so this is the input, so I'm going to plug now the output of the tracking generator to so let me turn it off, to this input, just like that. So maybe, okay, it's better if I do this. Okay, and then the output, which is this port here, I'm going to connect it to the input of the spectrum analyzer. Okay, again, I need an adapter from SMA to N. Okay. Ah, wrong direction. I'm making a mess here. Okay, so it should be more or less properly connected. Okay. Um, right, so now let me show it to you properly. So this is the attenuator. At the moment is set to the minimum, 6 dB. So I'm going now to run the tracking generator and see what happens. Okay, so we get our flat line at, as you can see here, or up there, at minus 6 dB as expected. Good. So now I'm going to turn the dial to 10 dB of attenuation. Let's see what happens. We are now at 10, and indeed this is confirmed by the reading of the spectrum analyzer up there. 10. So let me see if I can. Hopefully you can have. You can see. Yeah, we are at 10. So let me move now to 20. 20, and it's the reading on the spectrum analyzer is correct. Let's go to 30. Correct. 40. Oh, a little bit too much. Yes. 39 point something. Let's go to 50. And we are at 47. So let's go back to 40 for a second. Right. So there it's 40. 39 point something. The problem here is that we are reaching the limits of the noise floor of the spectrum analyzer. So let me reduce the internal attenuation of the spectrum analyzer. At the moment is set to 20 dB. Let me put it to 0 dB. Okay, so this reduces the noise floor. And so let me run the tracking generator again. Okay. So now, as you can see, we get our proper minus 40 dBm reading. So let me move to 50. And we get 49.9, so that's correct. Let's see, 60. I'm sorry it's not very well visible, but we are indeed at 60. And we are reading 60 on the spectrum analyzer, and now let's go to the maximum, 66, and we're reading 64, but again that's because we are in the proximity of the noise floor, I guess. Anyway, it's very very close to what it's supposed to be. So yeah, I think this works pretty well, and I'm very happy I found this for 50 euros, shipping included. As I said, there are still a few of them by this seller if you want, and I think that's it for this video. I hope you enjoyed. If you have any comments, feel free to leave them in the section below. I'll see you next time. Bye bye.